As in, the TCP IP reference model. Okay. I hope the voice is audible. The TCP IP model is a model that the actual internet is built on. It was developed before OS in the 1970s by DARPA and more bacterial or simplified. TCP/IP has four layers. Some versions of five. Okay. Layer 4 application layer combines OSI layers 5 plus 6 plus 7 where user applications live. I think I need to get a rough book in order to write the doubts that I am getting. So I will get a rough book. I also need to get some water because I will get thirsty soon. Okay. Yeah. So I think doing a 16-minute and a 10-minute thing is good, right? Okay, we are back to the routine cycle, and that's good to know. Alright, here we go. If you got any doubts, we can use them and we can write them in the book, and then it will be helpful um, when we write them back into the book. So here we go. Let's open ChatGPT simultaneously. What do you mean by failed to load subscription? I don't know. Why OSF? It is not used. OSI is used as a reference for understanding, teaching, and troubleshooting. When network engineers say that's a layer 3 problem or the issue is at layer 2, they are using OSI terminology. It is a language of networking. TCP/IP is what actually runs the internet. Okay, we have written all of this by the way. Coaxial, then conductor. Okay. Right, single mode fiber SMS very thin core 8 to 10 micrometers. Light travels in single path, one mode, very low signal, loss, very high bandwidth. Can travel very long distances, tens of kilometers. Expensive, requires laser lights was used for long distance communications. Internet backbone, multi-mode fiber, thicker core. 50 to 62.5 micrometers, light travels in multiple paths simultaneously. More signal distortion, model dispersion over distance, persists for image, shorter distances up to 2 kilometers, cheaper can use LED instead of laser, used for LANs, data centers, and short exposure fiber, not much bandwidth, terabits per second possible. No electromagnetic interference, light is immune to electrical noise, no electrical hazard, no electricity in the cable, very long distance, a single mode can go to 100 kilometers without amplification, security very hard to tap without physical cutting, cons of fiber, expensive cable and connectors cost more, fragile glass breaks more easily than copper, difficult displays requires precision equipment, one metal fiber, what does splice mean? Okay. by interweaving the strands of the answer. Okay, splice means to join or connect. What is the page number? Okay, 18. Okay, on paper fiber usually use two fibers, one for each direction. Unguided media, wireless, signals travel through the air or vacuum. No physical. Table three broad categories. Okay, this is an interesting question. Can internet travel through vacuum? Yes, internet can travel through vacuum, but it is not practical for long distances. Vacuum cleaners can generate electromagnetic interference which may disrupt vacuum. No, that is not what I have asked, right? Can internet travel through medium. The internet itself is not a physical substance, it's information carried by signals. These signals usually travel as electromagnetic waves. Electromagnetic waves do not need a material medium, they can propagate through vacuum because they are oscillations of electrical and magnetic fields, not vibration of particles. Satellites communicate across space, which is essentially vacuum using radio waves. What cannot travel through vacuum or mechanical waves, like sound needs particles to vibrate, so in space we cannot hear anything. But electromagnetic waves, which carry internet data and modulate the travel perfectly fine in vacuum. Okay. Radio waves contain frequencies from 3 kHz to 1 GHz travel through walls in long distances, omnidirectional, go in all directions, used in AM or FM radio, Wi-Fi 2.4 GHz, Bluetooth and cellular networks, problems, interference from other radio sources, microwave frequency 1 GHz to 300 GHz, travel in straight lines, line of sight required, using satellite communication, point-to-point links between buildings, 5G cellular, terrestrial microwave, towers every 50 to 80 kilometers for long distance links, satellite microwave signal goes up to satellite and back down. Infrared short range line of sight cannot pass through walls. Using TV remotes hold IRDA device connections. What is IRDA device? Not in this infrared based infrared based communication devices. Okay. I infrared based communication devices. Infrared Data Association. Okay, that indeed makes a lot of sense if you think about it. Advantage no regulation needed, do not interfere with radio. Disadvantage very short range, blocked by obstacles. Okay, you need to data link layer. The physical layer just transmits habits. It has no intelligence. It does not know which one message ends on the next begins. It does not know the bits are read correctly. The data link layer is responsible for framing. Okay, I did not start the clock, did I? Framing, organizing raw bits into meaningful units called frames, physical addressing using MAC address for local delivery, error detection and correction, making sure frames arrive correctly. Flow control, making sure a fast sender does not overrun a slow receiver. Media access control, managing who gets data transfer from multiple devices or a medium. Think of it as a smart driver that transforms physical layer into a reliable link between directly connected devices. So, what is MAC addresses and how they are used for local delivery and what is media access control? What is MAC address? Is it used in random and local delivery and what is media access control? Is it like and different from the things that we discussed before? Media access control networks is a unique hardware identifier assigned to network interface called NIC. Formally, it is usually a 48-bit number written in hexadecimal. It ensures every device in the local network has a unique identity for communication. The MAC is used in data link layers. Specifically, it is used for local delivery of frames within the LAN. Example, if your computer sends media access control. It defines how devices across the physical medium like Ethernet cable or Wi-Fi radio devices. Okay. MAC address is a unique hardware radio used for local delivery and data link layer media access control. Rules are protocols for accessing the medium. They are related to one the same. One is identifier, the other is a control mechanism. Okay. You have the capability of creating this 0%. What's the page number of it? It is a page number 20. Okay, write a few things down. It ensures that every device on the local network has a unique identity for communication. Media access control This thing is traditionally attractive. Framing the physical layers and the continuous stream of frames, there is no natural boundary, so does the receiver know where one message ends and the next begins. The data link layer group gets into frame structured units that define boundaries to approaches. Okay, fixed size framing, every frame has the same predetermined size, number of bits. Example, ATM asynchronous transfer mode cells exactly 53 bytes. Advantages, no need of framing markers, receiver knows exactly where each frame starts or ends. Every 53 bytes is a new frame. Disadvantage if data is not a multiple of the frame size, you waste space with padding, very inflexible variable size framing. Frames have different sizes. You need explicit markers to indicate frame boundaries. Two techniques character count include a field at the start of the frame specifying how many characters or bytes are in the frame. Receiver reads the count field, reads that many bytes, and then the next frame begins. Problem is the count field gets corrupted due to error. The receiver is lost. It cannot find the next frame boundary. Catastrophic errors, error cascades. Character stuffing byte stuffing uses special flag bytes to mark the start and end of each frame. Coming flags, HTLC flag. Problem, what if the flag appears inside actual data? Solution, stuffing. If the flag data appears inside data, insert an escape byte before it. Receiver, when it says an escape byte, it ignores the special message of the next byte. Sender scans data. If it encounters a flag byte, insert escape before it. If it encounters an escape, insert another escape. If it sees escape, remove the escape and treats next byte as a literal data. Bit stuffing instead of working byte by byte work as a bit level pattern. Yes, it's ones in a row surrounded by zeros. So after every five consecutive one bits in the data, automatically inserts a zero bit. Look at the nice piece of text. And yesterday we had a lab experiment on this vector and byte stuffing. I'm not expecting anything. I'm not the ignore and answer. So DLE STX and DLE takes Okay, it is taking a lot of time to load for some reason. Okay, my message just gone away. Am I supposed to type the entire thing again or what? God. Okay, I think we preserved it. Okay, that's a good thing. Yes, they are the same underlying concept. Whatever nodes in the manual are describing different protocols that uses. This is one of the topics where books often jump between examples without explaining the big picture. Let's build it from the ground up. Why do we need framing? Suppose the sender sends hello world, the receiver gets hello world. How does it know where one message ends and the next begins? Suppose two frames are sent, frame one and frame two. The wire actually carries frame 1, frame 2. The receiver needs some way to determine frame 1, frame 2. This process is called framing. There are several methods. Character count sender says 8. Okay, next 8 bytes belong to this frame problem. If the count gets corrupted 8 times, 80 receiver becomes completely confused. So this method is rarely used today. Character byte stuffing. This is what your lab is about. Instead of counting bytes, we surround every frame with special bytes. Start, data, and the receiver simply looks for start and. Suppose we choose start is equal to dollar sign and end is equal to hash and frame becomes okay. But what if data itself contains a hash? Now is and receiver themselves is a frame wrong. Escape character is another character escape whenever special characters occur inside data put escape before them. Okay. Suppose Helesco transmit Helesco no receiver removes the ask. Now where does DLE, and DLE come from? These are simply special ASCII control characters. ASCII contains many invisible control characters. Okay. STX means start of text, end of text. Okay. Data link escape. Okay. Okay. Instead of looking at bytes, it uses individual bits. If the six consecutive ones never appear inside data, the receiver may think frame ends. So the sender automatically inserts zero after every five one sequence of five ones. Example. Okay. 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 The receiver only removes a zero that comes immediately after five consecutive ones. Only four ones does not remove anything. So one should never occur in a validation for data if it receives if the receiver says six consecutive ones, it is interpreted as a part of a lag or it's in protocol and about sequence of ordinary data, so the algorithm is deterministic. Okay, so delimiter and delimiter. Delimiter matching. Okay, delimiter. It is not called pronounced as a delimiter. It is a delimiter. Okay. This is making perfectly sense to me. So what am I supposed to write now? Okay. Right, starting the HDLC file. What's the page number? 21 point and it's stopping. So let's summarize what we have. What not? So example to frame we can bytes let's see byte stopping we can use next can be HDLC like 6 numbers enclosed by zeros or special as the symbols like daily STX or daily UTX. So in this way, summarizing everything now. Okay. Data is ABCDLE XYZ. Okay, so daily STX ABCDLE DLE XYZ. Okay, works out. What does HDLC mean? What does HDLC mean? High level data link controller. Okay, HDLC stands for high level data link controller. See? Okay, we have written this character. So character stuffing can also be called as byte stuffing because one character occupies one byte of data. Okay, frame boundaries are marked using special bytes. Okay, all you need is to sit down and study for hours to be able to be good at anything. You already started the day. Okay, we can use ASCII. Today I yesterday I didn't start off frame daily ATX and frame of flag byte and like 0 double 1 double 1 double 1 0 is the HDLC flag. HDLC stands for high level data link control if I'm not wrong. Right? Controller. Okay. Example, data to be transmitted is A, B, C, D, E, X, Y, Z. What is sent is D, L, E, S, D, X, and after that A, B, C, D, L, E, D, L, E, X, Y, Z, D, L, E, E, to X. The thing that is received is A, B, C, D, L, E, X, Y, Z. DLE gets interpreted as a single DLE. Okay, the people who think at low level are really great. How do their reward mechanism work? Sometimes I will be curious. A bit stuff maybe the flag is 0 11 11 1 Same bit pattern may appear inside data. Um, Same bit pattern may appear inside data. So after every consecutive ones, sender inserts a zero. So five ones will become five ones and zero. So this guarantees flag 0 11 11 0 never appears inside the data. Okay, that is more than enough to write here. If I look oh god. Okay, okay, okay. Flow control. The sender might be fast. Example, a server within a fast processor and the receiver might be slow. Example, a node computer. If the send sends frames faster than the receiver can process them, frames pile up in the receiver's buffer and eventually get lost. Flow control. Okay. How fast to accept the data? The sender slows down accordingly. Two-main approaches: stop and wait. Sender sends one frame, then stops and waits for an acknowledgement. Receiver processes the frames and acknowledgement when ready. Very simple but very inefficient. Like asking a question, waiting for the answer, and asking the next question one at a time. Sliding window sender can have multiple frames in flight simultaneously without waiting for acknowledgement. The window says number of unacknowledged frames allowed at once. Receiver acknowledges frames as the ACKs arrive. Window slides forward, moves frames to be set much more efficient. It keeps the pipe full, like asking multiple questions at once and answering them in order. Without sliding window protocols in details, not like I have understood that. Error control. Physical media is not perfect. Noise interference, signal degradation can flip bit zeros become one and vice versa. Frames can also be lost entirely. Two types of error. Single bit error. Only one bit is flipped. First error. Multiple consecutive bits are corrected. Most common in real networks. Noise affects at best. Time. Error control detecting and error correcting is error. Two strategies: error detection plus retransmission. ARQ. Detect that error occurred after retransmit. Okay. What is ARQ stand for in error detection and retransmission? Shall we use like IS1 control shift DIC? Okay, why do you need camera? Okay, does ARQ, what does ARQ mean in error detection and retransmission? Very good. I don't know why it needs like camera. What does ARQ stand for in error detection and retransmission? Okay, that's pretty good. Automatic repeat request. Automatic repeat request. Okay, it then become AR if you use R and R here. That's why they used ARQ. That's good. I'm using a SIG negative timeout and sequence numbers. Automatic repeat request. Okay, that is good. What's the page number of this one again? 23. Give automatic repeat request. So A, R, and Q. Forward error correction. Okay. Redundancy to detect errors where redundant bits exit bits that are not data but contains information about the data. Is the redundant bit to we know a natural terminology like asking someone to repeat what they said is a repetition does not match what you heard, you know something went wrong. Parity is simplest method. Single bit parity, add one extra bit. Parity is to make the total number of ones bit even bit or odd bit. Data 10 11 count of ones were already even. So parity bit is 0. Okay, to make total even detection, receiver counts one bit. If count is even for even parity of each bond, error detected. Weakness can only detect odd number of bit flips. Two bits flipped, the parity is still correct, and parity cannot correct errors, only detect them. Two-dimensional parity, 2D parity, arrange bits in 2D grid, calculate parity for each row and each column, transmits the data plus all parity. Receiver recalculates row and column varieties, can detect burst errors and correct single bit errors. The failing row and failing column intersection tells you exactly which bit is wrong. Okay, so a two-dimensional parity can correct a single. What do you mean? A single bit error. Okay, that's all right. Cyclic redundancy check. I really doubt this voice chat. So I was reading this parity bit checking and single dimensional even or odd parity can detect even number of or odd number of errors. It can, if for example, if two bits are flipped, even bit parity cannot detect it. Okay, and two-dimensional parity can correct one bit error by seeing the intersection of the row and column and understanding where the bit was flipped. So similarly, can we generalize this? Like if we invented by some way a three-dimensional parity, can it like correct all the bits in the two dimension? Like is that how the generalization of this philosophy works? Oh wait, what? Okay, dude, I swear to God, I clicked right tick mark, right? Or did I not? Okay, is there any way to replay what's going on over here? I don't think so. But I don't know. It glitched for some reason. Anyways, we cannot do anything. Right. Okay, I will type it out. So even or odd parity can detect something went wrong, but can't correct it. And also it can only detect even or even or odd number of bit flips. But two-dimensional clarity can correct one bit error by identifying where the bit went wrong by looking at the intersection of the row and column. Can we generalize this philosophy by constructing a 3D parity checker and can assume it can correct all the errors that went in a row or column and how efficient would it be? Just is just a thought experiment. Yes, you can generalize parity for higher dimensions. No, it does not scale efficiently compared to codes like Hamming code, Reed Solomon code, or low density parity check code. Okay, okay. Unfortunately, different pair of flipped bits can produce the same pattern of parity failures. The decoder may not know which pair is actually wrong. This is called ambiguity. Okay. 4D hypercube. If you see, we are differentiating in power 4 here. That is elegant. Okay, everything is math if you go deep down. The flavor is engineering problem where the mathematics is underlying language to solve it. Can mathematician tell you why the star in it moves one person to tears while another revolves continuously? Platonist. Spiral following the Fibonacci sequence going approximately. Mathematics is a language in which universe is written. Okay. We are going into deep philosophy now. Okay, that is a good thought experiment. Okay, this I think I have understood it now. I don't need to write anything about it. Cyclic redundancy check is the most widely used error detection method. It's powerful, efficient, and implemented in hardware. The big idea. Think of CRC as a polynomial division. You treat the data bits as a polynomial divided by a known generator polynomial and the remainder of the division. It's a CRC. Why is it powerful? The mathematicians of the polynomial division. Because the mathematics of the polynomial division is very sensitive to changes. Even a single bit flip drastically changes the remainder. If the result CRC does not match the calculated CRC, we know there is an error. Okay, generator polynomial. Okay, okay, f of x, g of x. Can you call g of x as generator polynomial? GRC, okay. Binary. How is it like? How did it convert to binary? Okay, 1 0 1, all right. But this is not 15, is it? Okay, I don't know how it got converted to like binary. Let the data okay bits. Let the generator G have r plus 1 bits. Degree or polynomial. Append r zeros to the data. Append r zeros to the data. Whatever the new data. Okay, this seems to be the algorithm. Just like regular long division, but the fraction is replaced by XOR number. Zero XOR. Okay, exclusive or 110, right? Yeah. Yeah, this one is only the division difference between normal OR and XOR. Okay. I have not understood anything except the intuition. Can you explain the things that are going on? Right. Talk about math and everything. They throw around polynomials and division before telling you why they even exist. Let's build CRC from first principles. I'll only store one bit of information. That's a very big fingerprint. CRC is I will create a much richer fingerprint. What is fingerprint mathematics? Imagine two numbers, okay? Wow. In this phase of consumption of information, I would need break more frequently. I'm already exhausted. Wow. Okay, okay, okay. Okay. Every bit becomes a okay. Wait, this is like in the 17th place. Okay, okay, that makes sense. We are not calculating the value, we are calculating like this is 0, so that's why it is 1. This is 1, 2, that's why we got an x square here. And 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's why we got x power 15 and 16. We got x power 16. Wow. Okay, that makes sense. Ouch. Because ordinary division does not have a nice error detection properties that a polynomial division has. GF domains only two numbers exist. The remainder after dividing by a degree for polynomial can never have a degree 4 or more. Therefore, the remainder always fits inside 4 bits. Okay, I think I have understood it. Right. Ouch. Oh god, when did I like pass this? Is it been passed like a long time ago? Wow. How to check the, what's the time? Okay, I have been studying from like 55 minutes and I paused it and I was checking like why did not the timer move? Wow, that is for me. Okay, I will like take a break after like 1 hour's completed. I will put a 10-minute reminder and then I will come back again. I will just sit down and I will not talk anything. That's how I can refresh my brain again. Okay, I have understood this. So actually, I have understood some of it. At least I have understood how we have taken a polynomial from the stream of data. The other XOR operation and the way you have chosen the generator did not weren't clear to me, being honest, but I think deep diving into that would not be the best thing. to do for our objective. So I will proceed and if the exam specification that to do then say syndrome decoding. Okay, what is syndrome decoding? I'm going into the rabbit hole again. MIT Open Board Force. Checksum is simpler than CRC, but still effective used at higher layers, transport layer like TCP, UDP. Add all the data values, include the sum and the transmission receiver adds everything up. Should equal to a known value. Once complement internet checksum used in TCP/IP. Idea behind once complement in normal binary negate a number by flipping all bits by adding one. Two's complement in one's complement negate a number by just flipping all bits no plus one needed. Adding a number to its own complement gives only one zero. This property makes error checking simple. If the sum of all values including the checksum is equal to all ones, then it is okay. Divide the data into 16-bit segment. Add all add all segments using one's complement arithmetic. If the sum has a carry beyond 16 bits, repeat around. Because the checksum was chosen to make the sum all ones complement of all zeros and no corrections matched all ones. Okay. Data segments. Okay. Since 5 bits what we work with 4 with words have the carry. So the complement is okay. Okay, so the principle of wrapping was stated here. Like, what if you get an overflow? What are you supposed to do? That was mentioned here. It's been 1 hour. I will take a break. No, right. Yep. Except angle. Okay, that should be enough. Welcome back, people. Here we are. Okay, so we just worked with this checksum. The voice is audible, right? I hope I did not. Am I audible? Am I audible? I don't know if I am or if I am not because it is not showing anything important, like useful here. Let me just check out my channel to see if we are working properly. The voice could definitely be improved, right? Okay. Yeah, I have understood the voice is not clear enough, and that is not something that I can do about. I understood the voice is not clear for you people. Bear with it. Yeah, it's not like a lot of people are seeing this stream, but I still need to be accountable. Okay. We have studied checksum services provided by network layer and acknowledged connection as frames are sent without acknowledgement. No connection setup simple fast. If a frame is lost to band, used when errors are rare, fiber optic or latency is critical. Voice or video example Ethernet. Acknowledged connectionless frames are acknowledged. No connection setup if acknowledged not received within a time or retransmit used in unreliable wireless links. Example Wi-Fi. Acknowledged connection oriented. Connection is established first. Frames are sent and acknowledged in order. Connection is terminated at and most reliable. Example X.25 is the old wide area network protocol. Elementary protocols first build up from the simple to complex. Before we start terminology, acknowledge is an acknowledgement that says I received your frame successfully. NAK negative acknowledgement I received but there was an error. Timeout if sender does not receive ACK within the time limit, it assumes that the frame was lost and retransmits it. Simplex utopian protocol assumptions made to simplify one directional communication only. Sender to receiver communication channel is perfect, no errors, never lost frames. Receiver can process frames as fast as they arrive, no flow control needed. How it works, sender to receiver communication frame to frame to layers and frame. This is completely unrealistic but pedagogically useful. We start here and add complexity. What does pedagogy mean? I have heard this thing a lot of times. Pedagogy in the method and practice of teaching, especially as an academic subject or theoretical concept. Okay. Simplex stop and wait. Error free. Slow receiver. Receiver might be slow. Yet flow control. Still no errors. Similar get from okay. Now the sender sends one frame, waits for acknowledgement, then sends the next. This ensures the receiver never gets overwhelmed in efficiency. While waiting for ACK, the sender does nothing, use waste of time. Simplex protocol for noisy channel hierarchy. New assumption channels can have error frames may be lost or corrupted. This is called hierarchy automatic repeat request. Automatic because retransmission happens automatically. Error mechanisms needed. Error detection. Each frame includes a checksum or a CRC timer if ACK does not receive within a time. T retransmit sequence numbers critical to handle duplicates. Y sequence numbers, senders and frame 0, it arrives okay, receiver sends ACK, but ACK gets lost. Sender times out, retransmits frame 0, receiver gets frame 0 again without a sequence number. Receiver thinks this is a new frame, frame 1 gives it to upper layer, now the upper layer has frame 0 twice, duplicate. Solution number frames for stop and wait, we only need 1 bit 0 or 1 to distinguish current frame from the retransmitted frame. Okay, nice. Nice. This is making a lot of sense. Sliding window protocol. The problem is stop and wait. Extremely inefficient. The sender stops most of the time waiting. Link speed 1 Mbps. Propagation delay 5 milliseconds. Satellite link 15 millisecond. Frame size is 100,000 bits. Transmission time is 1 millisecond. Round trip time is 10 milliseconds. So 91% of the time is wasted. The solution that the sender send multiple frames before waiting for acknowledgement. Efficiency. Okay. If W is large enough to keep the link busy, efficiency will limit to like will travel to or maybe tens to 100%. Tens is the word that we are supposed to use. The optimal window size. Okay, one bit sliding window. Stop and wait is actually this with W is equals to 1. Not much different from stop and wait uses one bit sequence numbers alternate. Go back and sender can have to up to n acknowledged frames outstanding at a time. Sequence numbers need more than one bit with k bits of per sequence numbers. You can have 2 per k possible combinations. For G backend. Okay. Cumulative ACK means I have received all the frames up to including and correctly. One ACK can acknowledge multiple frames. It only accepts frames in order. Any out of frame is discarded. Receiver maintains no buffer. Simple receiver, no buffering needed. Found very wasteful. If one frame is lost with a large window, you transmit many frames that were already received smoothly. Bad for links with high error rates. Okay. Okay, I don't know. Selective repeat problem with go back and retransmitting correctly received frames is wasteful. Okay, retransmitting correctly received frames is wasteful. Selective repeat solution. Receiver can accept out of frames and buffer them. Only the missing frames need to be retransmitted. Window size for SR. Okay, bits both sender and receiver windows less than 2 power k minus 1. Hmm. Okay. Stop and wait. Go back and selective repeat. Okay, this makes sense. HDLC, a bit-oriented data link protocol that uses bit stuffing for framing, widely used as the basis of many other protocols. Right, oh God. We are at 33 pages. Almost we have completed one third. Technically, we did not read the first 20 pages, so that doesn't count. A bit-oriented data protocol used for bit stuffing for framing, widely used as a basis for many other protocols. Okay. can control data frame check sequence CRC for armor reduction. Three frame types determined by control field. One frames. Yes frame. Okay. I frames, information frames, S frames, supervisory frames, U frames, unnumbered frames. Okay. SAVM set asynchronous balance move to establish connection. Yes, it is. What is DISA in this context? What is DISA in this context? Okay, DISC means disconnect. Okay, expected happening on termination. Unnumbered acknowledgement. PPP point to point protocol. A data link protocol for point-to-point connections. One device directly connected with another, no shared medium. Your home internet connection when you connect your ISP via DSL cable modem or fiber PPP or PPPoE, PPP or Ethernet is commonly used. And the data link layer framing defines clear frame format uses flag bytes like HDLC. Link control protocol establishes, configures, and tests the data link connection, negotiate options, compression, authentication method, etc. Network control protocol (MCP) different MCP for each network layer protocol. IPCP for IP. IPFCP configures network layer authentication protocol. EAP password authentication protocol. And CHAP challenge handshake authentication protocol. Okay. Unit 2 is completed. For God's sake. And what do you think is like better option? Should we switch subject because that would be more interesting instead of just brute forcing this entire computer networks because you wouldn't need to worry until first mid if I were to be honest. So if you complete this, we still have not touched entrepreneurship and we still have supposed to write a mid exam for that. And there is OAD. I think Kusha ma'am is going to cover that, but still, we still have this thing called as data mining, data mining. Yeah. How many pages is it? 54 pages. Not too bad. Snowflakes. Mhm. Yeah, I think this is going to go pretty smoothly. this is mostly a theoretical subject, and these people uh, are going to provide lesser insights than what I study here. So I think I need to organize a few stuff here. Like I will cut this thing. And I will paste this thing here. Okay. Just to be sure, I have performed the data mining lab, and it is not that scary of a thing. And we still got like 44 minutes. Let me just open this. Yeah, I don't think we will be like reading all of these things like AMZ, QZ. I think you might have seen that on this accounts of mine. Okay, what are we supposed to do now is we are supposed to like open Cloud, coffee and Cloud time. Okay, maybe you are living in a hallucination. The first thing is to crack gate. Okay, let me just get this syllabus of mine, and we are yet to completely like practically cover the OID syllabus. We did not comprehensively cover that, did we? And these are a lot of PDFs that we. Okay. Yeah, this is the one. Write the exam ready notes for this one. Don't assume any direct results. Reread with this and explain it deep enough and simple enough. Don't skip anything. Don't make any document or PDF. Start writing the 5 minutes now. One. Okay, I think this should be like enough. Did I just like copy all of that? I guess I copied all of that. Okay, we will let it complete it, and after that we will also make it write some entrepreneurship. Where is this entrepreneurship? Formal languages and automated computer networks, data warehousing and data mining. No, we do not have that. Where is entrepreneurship too? Huh? Okay, no idea. Okay, this is professional core, this is professional core, this is professional core, professional elective. Okay, this was elected by these people. Open elective entrepreneurship. Entrepreneurship. Where is this then? ENTRE. Is it like the only place? It got 3 credits. He's not going to give you 3 credits just for free like that, right? And there is no syllabus. Like it was said, like entrepreneurship is there, and there are 3 credits for that, and there is no syllabus. So ये तो questions देंगे और हम like लिखेंगे क्या? Okay, let's ask ChatGPT about it then. Yes. Unified means it combines the best ideas from Grady Boost method, James Ramberg's OMT object modeling technique, Ivar Jacobson's OOS, object-oriented software engineering. Okay, it is going too deep to be honest. Okay, not too bad. Yeah, I think making it a PDF will preserve the structure. Okay, it is a good text generator. I will give it that. Entrepreneur. Entrepreneurship. Syllabus, we cannot do anything about it. So we will just read the units of already touched in this session. Then 2 units are created. Then we will start the cycle for the remaining 3 minutes. For these 3 examples. Then we will get to the solving. Okay, that is making a lot of sounds of mystery. Shonen Seinen Shoujo Joshi. Yeah, it is completed. Class diagrams, object diagrams, component diagrams, deployment package, composition, profile, use case, sequence, communication, state machine, activity, interaction. Okay. Standby, activate. Okay, not too bad, I would say. Okay, and the 3 1. Okay, since we do not have anything to do on entrepreneurship, we are not going to just do it. How to rate it? It is worth of like rating. Okay. Yeah, there is like a lot of free AI available right now, and you don't need to pay for anything if you dig down deep into the rabbit hole. Okay. Now, what are you supposed to do? Is you are supposed to. Did I like push it into stuff? गंगाधरा शिव गंगाधरा हर हर भोले. This music always gives me goosebumps. Where is this word? Yep, here it is. Before we dive into software, let's understand what complex means. A complex system is any system that has many parts that interact with each other in many ways and where the behavior of one or the whole cannot easily be predicted by just looking at the individual part. For example, the human brain, billions of neurons interact in the internet, millions of computers connected. A large software application, thousands of modules working together, the structure. This means the complex system can be made of subsystems, and each subsystem is made of smaller subsystems and so on until you reach the smallest elementary component. Example, think of a university, department, sections, classroom, students. Each level is a subsystem of the level above. This hierarchical nature was observed by Herbert Simon, a Nobel Prize winner. He noted that complexity frequency takes the form of hierarchy, where a complex system is composed of interrelated subsystems, each of which is in turn a hierarchical structure until we reach some lower level elementary subsystem. What does hierarchical structure matter? It allows us to understand one part at a time. It allows us to see one part without affecting everywhere else. It allows the use of subsystems, the inherent complexity of software. Software is one of the most complex things humans have ever built. Here is why software is inherently complex. The complexity of the problem domain. The real world is complex. Software must model the real world, so it inherits that complexity. For example, a banking software must handle thousands of rules about transactions, taxes, regulations around etc. The difficulty of managing the development process around software is built by teams. Coordinating hundreds of developers, testers, managers, and clients is extremely hard. Communication gaps leads to misunderstandings. The flexibility possible through software, unlike hardware, which is physical and rigid, software can do almost anything. This is unlimited flexibility that occurs because it means there are infinite ways to solve a problem and choosing the wrong way creates disaster. The problems of characterizing the behavior of discrete systems. Software is a discrete system. It jumps from one state to another like a switch on off, unlike continuous system like water flowing. Discrete system can have an astronomical number of possible states. Testing every state is impossible. Key inside the essential complexity of software cannot be eliminated. It is inherent to the problem, but we can manage it through good design and organization. Attributes of a complex system according to Bosch. Complex systems share these five attributes: hierarchy of nature, as discussed above. Complex systems are made of subsystems, and so on. Relative primitives. Uh, what counts as elementary depends on the level you are looking at. A transistor is primitive to a chip designer, a chip is primitive to a circuit board designer, a circuit board is primitive to a computer architect. In software, a function is primitive to a module designer, a module is primitive to a system designer. Separation of concerns and tri-unit versus inter-unit interactions inside a subsystem. Parts interact heavily with each other. Inter-unit between subsystems interaction is limited as well-defined. Inter-unit this separation is what makes the system understandable in software. Why this is why we hide internal details. A user of a function does not need to know how it works internally. Alright, this is making a lot of sense and this seems a lot more sustainable and this also helps us in our vibe coding and building our projects. So I should dedicate my weekends to this instead of that. Okay, 1 hour 47 minutes. We are into this and we have had a lot of insights. Okay, common patterns. Complex systems are full of patterns. Nature reuse patterns being new factors. Software can also reuse patterns, design patterns, recognize common patterns, simplifies understanding. Stable intermediate forms. Complex systems are worked on simpler steps. A stable intermediate form is a simple working system that becomes the foundation for the next level. First, we build simple calculators, then simple computers, then complex computers. Each stage enables the next. Organized versus disorganized complexity. It is organized complexity. A large number of parts that are essentially random in behavior can be handled using statistics and probability. Example, gas molecules in a container. You don't know where each molecule is, but you can predict average pressure. Organized complexity. A large number of parts that interact in a specific non-random way cannot be handled with statistics alone. Requires the understanding of structure and relationship. Examples: a living cell, an ecosystem, a software system. Software systems fall under organized complexity. That is where you cannot just throw a random code together. You need structure, design, and planning. Bringing order to chaos in software is complex. How do we manage it? We use five approaches: decomposition, break a larger problem into smaller, more manageable subproblems, solve each subproblem separately. These are two classic ways to decompose: algorithmic decomposition, break the system into steps, procedures, or functions. This is a traditional approach. Object-oriented decomposition breaks the system into objects that things that exist in the problem domain. This is a modern approach. Object-oriented decomposition is better because it maps more naturally to the real world. Abstraction focuses on essential characteristics of something and ignores the irrelevant details. Example, when you drive a car, you think of the steering wheel, accelerator, and brake. You do not think about the internal combustion engine. That's car interface. Steering pedals is an abstraction of the complex internal machinery. In software, a function is an abstraction. You can calculate tax income without worrying about how it is implemented. Hierarchy organize abstraction into levels. Higher levels are more abstract, lower levels are more detailed. In a payroll system, level 1 payroll system, level 2 employee management, payment processing, report generation, level 3 for employee management, add employee, remove employee, update employee, modularity, divide the system into modules, self-contained units with clear interfaces. A module hides its internal details and communicates with other modules only through defined interfaces. Benefits: each module can be developed independently. A change in one module does not break others. Okay. What would be the path for a millionaire? Each module can be developed independently. A change in one module does not break others. Modules can be reused. Patterns: recognize and reuse proven solutions to common problems. Do not reinvent the wheel. Design patterns like singleton, factory, observable examples. Pre-proven solutions to recurring design problems. Designing complex systems. When designing complex systems, we follow these key principles. Principle 1: divide and conquer. No human mind can hold an entire complex system in its head at once, so we divide it into manageable pieces. Principle 2: maintain a clear distinction between interface and implementation. The interface is what a module offers to the outside world. The implementation is how the module does it. Internally, users depend only on interface. They do not care about implementation. Principle 3: build systems incrementally. Do not try to build the entire system at once. Build a working core first. A stable intermediate form, then add features step by step. Principle 4: give priority to the architecture. Give overall architecture. System infrastructure is the most important property. A good architecture makes everything else easier. Use hierarchies organize the system into layers. Each layer provides services to the layer above it and uses the services from the layer below it. Case study system architecture, satellite-based navigation. This case study GPS navigation system illustrates how physical complex systems are structured and designed. What is a satellite-based navigation system? A GPS global positioning system calculates your exact position on Earth using signals from satellites. Components of the system: space segment, multiple satellites orbiting Earth. Each satellite continuously broadcasts its location and time. Control segment: ground stations that monitor and control the satellites. They correct satellite logs and update orbital speed. User segment: the GPS receives in your phone or car receives signals from at least four satellites, calculates position using trilateration, measures distances from multiple known points. How does trilateration work? Each satellite tells the receiver you are X kilometer away from me. With signals from four satellites, the receiver can calculate its exact 3D position, latitude, longitude, altitude, and correct its log. How this illustrates complex system design, hierarchical structure, space control, user segments. Principal decomposition: each segment broken into subsystems. Abstraction: user only sees your location on the satellite map. Modularity: each segment is independent, communicates via radio signals. Stable intermediate forms: basic positioning, then adding maps, then turn, by turn direction. Key object-oriented concepts visible here: classes, satellite, ground station, receiver, signal, position. Relationship: satellites and signals, receiver processes signals to calculate position, hierarchy, navigation system, space segment, satellite. This is making a lot of sense, honestly, and it is going at a reading comprehension speed. 1 hour 54 minutes. Okay. Okay, let's inspect this guy's YouTube channel. All right, we completed first unit and we are down to second unit. I think we can read it out in like 15 minutes. Yeah, I think we can do read it out in 15 minutes. What is modeling and why is it important? A model is a simplified representation of something real built to understand, communicate, or analyze it before or during building the real thing. Example: architects build scale models of buildings before construction, engineers build circuit diagrams before building actual circuits. Software engineers build UML diagrams before writing code. Why is modeling important? Visualization: model that you see the system before it exists. You can spot problems early. Specifications: model precisely define what the system should do and how it should be structured. Construction: models guide the development process. Code is generated from or at least guided by models. Documentation: models serve as documentation for the system for future developers, maintainers, and users. Key rule: the more complex the system, the more important modeling becomes. Principles of modeling: Bosch identifies four fundamental principles of modeling. Principle 1: the choice of what models to create has a profound influence on how a problem is attacked and how a solution is shaped. Different models highlight different aspects. A model that shows only the data flow is different from one that shows object interaction. Choose models that best capture the system's critical aspects. Principle 2: every model may be expressed at different levels of precision. When talking to a client, you use a high-level abstract model, no technical details. When talking to a developer, you use a detailed, precise model with exact data types and methods. Same system, different detail levels. Principle 3: the best methods are connected to reality. A model of a bridge must follow the laws of physics. A software model must reflect how the real system will actually behave. Models disconnected from reality are useless or dangerous. Principle 4: no single model is sufficient. Building many plans: road plan, electric plan, plumbing plan, structural plan. Similarly, a software system needs multiple models: structural model, behavioral model, deployment model, etc., each capturing a different viewpoint. Object-oriented modeling. What is object-oriented modeling? It is a approach of modeling a system as a collection of objects where each object represents something from the real world or problem domain and has state, data, or attributes. What the object knows: behavior, methods, or operations. What the object can do: identity, a unique existence. Why object model? Why object-oriented model? Traditional algorithmic approach models the system as a series of steps, like procedures, problem, what requirements change, procedures change, trust, when requirements change, procedures change drastically. Object-oriented model models the systems as objects that interact. Objects are more stable than procedures. The things in the problem can change less than the steps. For example, in a banking system, account, customer, transactions are stable concepts. The specific procedures may change, but these things still connect. Core concepts of object-oriented modeling: a real-world entity with state and object is a real-world entity with state and behavior. Example: account 123 is an object of class bank account. Class, a blueprint or template for creating objects. Example: bank account is a class defining that every bank account has balance, account number, and can deposit, withdraw. Encapsulation, hiding internal details, only exposing a public interface. Inheritance, a class. A child class inherits attributes and methods from a parent class. Example: saving accounts inherit from bank account and adds interest rate. Polymorphism, the same operation behaves differently in different classes. Example: a draw method different behaves differently for circle, rectangle, and triangle. Abstraction represents essential features without background detail. Conceptual model of UML. What is UML? Unified Modeling Language. It is a standardized visible language for specifying, visualizing, constructing, and documenting the artifacts of a software system. Unified because it combines the best ideas from Grady Putz's method, James Rambach's OMT object modeling technique, Ivar Jacobson's OIC object-oriented software engineering. These are called the three amigos. Three amigos. Okay, this seems good. Three amigos. Three amigos of UML. Grady Butch, Ivar Jackson. Okay, the three amigos. So it seems to be a pop culture related meme or something. Yep, these are like three amigos. Okay. 1986 is a Western comedy about three out of work silent film actors who mistaken for real gunfighters for a Mexican village threatened by a bandit unwittingly agree to help. Okay, so it is a pop reference or maybe a Western reference. Alright. What UML is not, it is not a programming language, it is not a methodology or process, it does not tell you how to develop software, just how to model it. It is not only for object oriented systems, though that's the primary use. The building blocks of UML. UML has three main building blocks. Things are the basic elements in UML. There are four kinds: structural links, nouns, what exists, class, interference, collaboration, use case, component, node, behavioral things, verbs, what happens, interaction, message between objects, state machine, grouping things, container, package, a group of related elements, annotational things, explanation, note, a comment attached to a diagram element. Relationships connect things together. The four main relationships are: one element uses another, objects are okay, dependency, association, generalization, realization. Solid line with a hollow triangle, dashed line with a hollow triangle. Diagrams are views of model. What are the four main relationships of UML diagrams? What are the four main relationships of UML diagrams and how are those four diagrams? Like, what are those? Wait, why is it not moving? Dependency association generalization realization. Dependency association generalization and realization. Can you provide me some insights on these things? Suppose we have two classes A and B, there are only a few meaningful ways they can be related. Uses knows is a implement. A uses B, A knows B, A is a B, A implements B. The weakest relationship, chef one night, does a chef own every night? No, he simply uses one while cooking, that's a dependency. Okay. Printer merely uses document, it does not store it, it does not own a document can disappear after the function finishes. Printer depends on document. Association, teacher and student, teacher not student, student not teacher, this relationship exists over time. Okay. Generalization, this is probably the easiest animal. Dog is an animal. Class dog actions animal. Okay. Realization, extending a class. Flyable, fly. Bird implements flyable. But instead of extending a class, you implement an interface. I promise to provide these methods. Generalization inherits implementation, generalization inherits specialization. Okay, bird gets nothing. Bird must write, fly itself. So interface only specifies what, not how. Printer uses document, teacher as student, dog is an animal, bird implements flyable. Everything seems to reduce to math. Do I simply use you? Do I have you? Am I you? Do I promise your behavior? Wow. Okay, this ChatGPT is becoming like better at explaining. Wow, okay, okay. 2 hours and 5 minutes. We still got like 5 minutes to go. We will write these four things. What's the page number? It's of page number 10. 10. Okay. Where is it? Explanation of the four relationships. I will get back to you regarding that. I think I'm supposed to eat. Should I be stopping the streaming? No, I don't think I should be stopping the streaming. I think I will take a break of 30 minutes after this. Okay, I think we can have another session, or maybe not because he already cooked food for me. Right. There are only, I suppose. First we have full classes. There are four meaningful ways that they can be related. Dependency versus uh, generalization is a realization. Printer uses document doesn't store on a teacher. A dog is an animal. A bird implements the the main difference between this generalization and realization is mathematical maturity. Dog implements inherits. Already implemented generalization. A bird is a flyable being, but it must implement its own mechanism. Its own mechanism of how to fly. That's why the flyable is an interface. Dog is an animal. Bird implements flyable. Okay, I'm going to take some break, everybody. Maybe a break for like 30 minutes, and then I will come back at this. Okay, so Right. I am now after I had my lunch tasks. I just extend this and it is quarter to 12, so I should be able to come back before 12:15. I hope I will. I'm muting this. Yeah. Here we come back again, people. So we will study for another hour, and then we will take a break. So we will study data warehousing and data mining this time. Right. Where is this one? Yep, here it is. I will just make it a PDF and then I will study it. Right, that should be enough. I think we should be able to complete this PDF, at least half of it in this 1 hour. Before we begin, what problem are we solving? Imagine you're on a big supermarket chain with 500 stores across India. Every day, millions of items are sold, millions of transactions happen, data pours in from every store every second. Now, your CEO asks what were the total sales of rice in Andhra Pradesh in quarter 1 of 2024 compared to quarter 1 of 2023. Your regular database like MySQL is not built for this. It is built for add this item to cart, update the customer's address, fast, small, one row at a time procedures or operations. Answering the CEO's questions requires scanning of millions of rows, joining multiple tables, grouping aggregation. This would take hours on regular database and would slow down your live store operations. This is exactly the problem data warehousing solves. What is a data warehouse? A data warehouse is a large centralized repository of data collected from multiple sources, specially designed for analysis and decision making, not the day-to-day operations. Think of like regular database, OLTP, data warehouse, OLAP, like cashier still handles transactions fast. Like a company's archive room stores everything for analysis, updated constantly real time, updated periodical data every or weekly, stores current data, stores historical data, optimized for insert or update or delete, optimized for select or group by or aggregate. Small queries, few rows, used queries, millions of rows, used by clerks, cashiers, used by analysts, managers, CEOs. Key definition by WH. I'm on the father of data warehousing. A data warehouse is a subject-oriented, integrated, non-volatile, and time-variant collection of data in support of management decisions. Let's break that definition word by word. Subject-oriented, organized around subjects like sales, products, customers, not around applications like billing system or inventory system. Focuses on what the business cares about, not how the software works. Integrated data comes from many different sources, different stores, different software, different formats, all brought together in one consistent format. Example, one system calls gender MRF, another uses male or female data warehouse standardizes it to one format. Non-volatile once data enters the warehouse, it is not deleted or updated. You only add data, never change past records. This preserves the historical record, crucial for trend analysis. Time variant. Every piece of data is stamped with time. You can look at sales from January 2020, March 2022, etc. Regular databases often only store the current data. Why does a data warehouse exist? The purpose. Business need to understand the past, what happened, reporting, understand the present, what is happening now, monitoring, predict the future, what will happen, data mining or ML. This is called business intelligence. A data warehouse is the foundation of business intelligence. OLTP versus OLAP, the core distinction. This is one of the most important comparisons in the course. Online transaction processing, online analytical processing. Run daily operations, analyze data for decisions, clerks, cashiers, operators, analysts, markets, executives. Simple, insert, update or delete. Complex aggregations, comparisons. Data, current, operational, historical, consolidated, response time, milliseconds. Response time, seconds to minutes, GBs, TBs to TBs. Example, process this order. Show me total orders by region last year. The architecture of a data warehouse. Here is how a data warehouse is built step by step. Source system, ETL process, data warehouse front end, sales database, extract, transform, load, central database, data warehouse, data marts, reports, dashboards, mining, external data, step one, source systems. These are your regular operational databases, sales system, HR system, CRM, lab logs, external market data, What does CRM mean? Like customer, what is it again? Customer relationship management. Yeah, customer relationship management. What is the abbreviation of CRM? Customer relationship management. Yeah. Need a minute. ETL, the heart of the pipeline, extract, transform, load, extract, pull data from all data sources. From all source systems, transform, clean it, standardize it, fix errors, convert formats, load. Push it into the data warehouse. This is often a nightly batch job, runs at midnight when traffic is low. Data warehouse or data marts. Data warehouse, a full central repository. All departments, all data, data mart, a small focused about a subset of data warehouse at one department. Example, sales data mart, finance data mart. Think of data warehouse as a whole, like daily data mart as one section of it. OLAP and reporting tools that allow users to query and visualize the data like Tableau, Power BI, or custom dashboards. Tableau, Tableau, Tableau. Okay. Now we need to organize data inside the warehouse. This is called modeling. The most popular approach is dimensional modeling, which uses the star schema. Imagine a star, the center, fact table, the points, dimension tables. Okay, fact table contains the measurable quantitative data, the numbers you want to analyze, example, sales amount, quantity sold, revenue, profit. Also contains foreign keys pointing to dimension tables, usually very large, millions of rows. Dimension tables contains descriptive categorical data, the context around the numbers. Example, product name, category, brand, store location, region, time, day, month, year, quarter, customer, city. Okay. Usually smaller. For example, fact table, sales fact, time, product ID, store ID, customer ID, sales amount, quantity, okay, time ID, day, month, quarter, year, dimension. Note on the total sales price in quarter one of 2024. You join these tables by Snowflake schema. Wherein the star schema is dimension tables are further normalized, split into more categories. Dimension tables are split. Denormalized dimension tables are split. Normalized. Faster queries, fewer joins, save storage space. More data redundancy, less data redundancy, simpler to understand, more complex. Preferred for OLAP use when storage matters. The data cube, the key concept of OLAP. This is one of the most important and beautiful concepts of data warehousing. Intuition first imagine a spreadsheet. It has rows and columns. That's two dimensions. Now imagine you have three dimensions: product, time, and location. You can think of a 3D cube where one axis is equal to products, one axis is equal to time, one axis is equal to location. Each cell in this cube is equal to a value. First total sales value in Hyderabad in January. This is a data cube. Because you can slice, dice, rotate, drill into this cube to answer any question from any angle. OLAP operations are 5 key operations. These are the operations you can perform on a data cube. Roll up or drill down, moving from detailed data to summarized data, doing with the hierarchy example from daily sales to monthly sales to quarterly sales to yearly sales. From cities to state to country, you are zooming out to see the big picture, drill down, roll down. The opposite, moving from summary to detail, going on the hierarchy example, you see yearly sales are loaded down to quarterly, monthly, fine. January was bad, drill down to daily, fine. January 26 had a spike. You are zooming in to find the root cause. Slice. Cutting the cube along one dimension, fixing one dimension's value. Example, show me all data from for January only. Utilize the time dimension at January. Result, a 2D sheet. Product times location for January. Next slicing out of operate. You get one slice. Dice cutting the cube into multiple dimensions. Show me data for rice and wheat in Hyderabad and Chennai for quarter one. You are selecting a smaller subcube like cutting a small cube from a big cube. Pivot rotate. Rotating the cube to view data from a different angle. Example, rows were products, columns were months. Pivot rows are now months, columns, or products. Like rotating a Rubik's cube to look at a different face, same data, different perspective. Data warehouse design and usage. The four steps of data warehouse design. Choose the business process. What are you analyzing? Sales, HR, finance. Example, we want to analyze retail sales. Choose the grain. Grain is equal to the lowest level of detail every store. Example, one drop per individual product sold per transaction. Fine grain, more detail, more storage. Coarse grain, less detail, less storage. Always choose the finest grain possible. You can always roll up, but you cannot drill down beyond what is stored. Choose the dimensions, what context surrounds each fact. Example, time, product, store, customer, promotion. What numbers will you measure? Example, sales amount, units sold, discount given, profit. Data warehouse implementation indexes used in data warehouse. Bitmap index used for columns with row cardinality, few unique values like gender, male or female, region, north, south, east or west. Instead of storing values, stores a bit array. Zeros and ones, very fast for filtering. Show me all female customers in south, just and the two-bit arrays. Not suitable for high cardinality columns like customer ID with unique of millions of unique values. Join index pre-computes the join between fact and dimension table, speeds up queries dramatically. Materialized views. Pre-computed queries stored as actual tables like caching instead of computing total sales very easy and every time compute it once and store it. Trades storage for speed. Cloud data warehouse. Traditional data warehouses ran on physical servers in the company's own data center. Cloud data warehouse moves bits to the internet cloud. Popular cloud data warehouse solutions: Amazon Redshift, AWS, Google BigQuery, Google Cloud, Snowflake, Multi-Cloud, Azure Synapse, Microsoft. Why cloud data warehouse? Traditional data warehouse expensive, hard to buy. Cloud data warehouse pay only what you use. Fixed capacity, scale up or scale down instantly. You manage servers, providers manages infrastructure. Slow to set up, months, ready in minutes. Physical location accessible from anywhere. Introduction to data mining. Data mining is the process of discovering hidden patterns, correlations, anomalies, and useful knowledge from large data sets automatically. The terms come from the analogy of gold mining. You sift through a lot of material data to find valuable nuggets, patterns, or knowledge. The KDD process, knowledge discovery in database. Data mining is actually one step in a larger process called KDD, raw data cleaning, data integration, data selection, data transformation, data mining, pattern evaluation, knowledge presentation. Most people use data mining loosely to mean the entire KDD process. That is okay for now. What is it? Knowledge discovery in databases. What kind of patterns can data mining find? Association, things that go together. People who buy bread also buy bread butter 80% of the time. Classification assigned items to categories. This email is spam or not spam. Clustering group similar items. These 10,000 customers form three distinct groups. Regression predict a number. The house will sell for 45x. Anomaly detection. Find unusual items. This transaction looks fraudulent. Sequence mining. Find that patterns in order. User will search X, then Y, then Z. Usually by Z plus 1. Technologies behind data mining. Data mining uses techniques from statistics, mean variance, correlation, regression, machine learning, decision trees, neural networks, SVM, support vector machine if I'm not wrong, database system, SQL, indexing, query optimization, information retrieval, fetch, text mining, visualization, charts, graphs, and dashboards. Really simple. I think, yeah. So the thing is, we are not using those daily grades. Okay, I will like stop the streaming for a moment and let's see if I like got any messages from anybody. Okay. I did not get any messages. Yeah, I think credit is all the monthly credits or something. Yesterday. I think implementing one phase at a day is important, or better than trying to put all of that in one. So it's been already like 3 hours.